Well, welcome everyone to the Computer History Museum for our special program tonight. My name is Dan Lewin. I'm the CEO of the museum. Been here for a little more than 4 years, and so it's nice to see so many of you, some in masks. It's your choice, but 2 years of the pandemic has been part of our life here. This is a special evening for all of us as we have evolved the museum's mission and focused on decoding technology, the computing past, the digital present, and the future impact on humanity. This program tonight really launches a whole initiative that we're undertaking for the year. We start in July with our fiscal year, that we call the Art of Code. And it really is the case that Smalltalk created the foundation for so much of what we all live and breathe and work with every day, because as we all know, life doesn't exist without computing. And this program has generated incredible enthusiasm. Obviously, you're all physically here, but there are a lot of people online tonight as well. And most of you probably are aware or noticed on the way in that we have our Hall of Fellows plaques on the wall out there. And these are notable pioneers in the industry. And this evening, there are either in the audience or online 7 of the CHM Fellows participating. But with Dan and Adele, there will be 9, because in another month or so, Dan and Adele will be joining that. And there's 3 or 4 Turing Award winners hanging around somewhere, either in here or online, and some ACM. You know, there's a few people that care about this program and this milestone. So the anniversary is a special time, and I'm proud to be introducing Marguerite Gong Hancock, who's a special member of the team who is designing our programming and also responsible for our Exponential Center, which is where we think about the exponential impact of these technologies on our lives as humans. Because again, thanks to this work, we live and breathe without computers. Thanks. Marguerite.
So much, Daniel. Thank you. Well, good evening, and I'm delighted to add my warm welcome to each of you who are joining us for tonight. Our program tonight, Making Smalltalk, but we're really talking about big ideas. And as Daniel said, we are kicking off this year-long exploration and celebration of the art of code. And for more than 50 years, people have been discussing, debating computer programming or code. Is it art? Is it science? Is it engineering? Maybe all three. And as we explore this, we're going to be thinking about software code in several ways. One is we're going to be featuring historic pioneers on stage. We'll be releasing source code on special anniversaries, including the 40th anniversary of PostScript, and also Lisa and others that we will announce as the year goes on. We're also going to explore the creation of software programming languages today and think about sort of the issues and implication of what might come next. So tonight, as we celebrate the 50th anniversary of Smalltalk, happy birthday, Smalltalk. Many of you may be very, very familiar with what Smalltalk is, but others have been asking, what is Smalltalk? Here's a little video that our team has prepared to answer that question.
Smalltalk is a pioneering object-oriented programming language initially developed by Alan Kay at Xerox Palo Alto Research Center, PARC. Dan Ingalls implemented most of the early versions with the help of Ted Kaler, Diana Mary Shapiro, and others. Adele Goldberg, as research laboratory manager, drove the public release of Smalltalk in publications, classrooms, and the computer industry with the help of David Robson, Glenn Krasner, and others. Inspired by Seymour Papert's logo language for teaching young children, Kay envisioned Smalltalk as a way for children to learn by modeling and simulating the real world. Kay found that as programs got larger, they became more unwieldy, more error-prone, and more difficult to debug and revise. He wanted to create a programming architecture that could scale software from the very small to the very large, without losing its flexibility nor its stability. The object-oriented programming model was used to respond to this problem. Kay reasoned that you should split problems into simple components, or objects, that would communicate by exchanging messages. He thought of it as an operating system, a tool-making environment in which the user could not only use tools, but construct their own. The makers of Smalltalk invented much of the modern graphical user interface, including overlapping windows and pop-up menus, more than 50 years ago, 12 years before the first Apple Macintosh was released. As one of the pioneering object-oriented languages, it has influenced many currently popular languages such as Python, Java, JavaScript, Ruby, and Objective-C, used by many millions of people around the world. Extreme programming and Scrum both got invented in the Smalltalk community, leading to today's agile development methods used throughout the software industry.
Thank you. Special acknowledgement to our lead curator for this Smalltalk, Dr. Hanson Shu, and our media team and others who worked on that. So as we look back at Smalltalk, we're really thrilled to have 3 of the co-creators here with us as we discuss that. Alan Kay unfortunately could not be with us this evening, but he's worked really closely with our team to create some comments that we'll be sharing throughout the evening via video. And as Daniel mentioned, we're really thrilled on stage to be featuring 2 of our soon-to-be honored distinguished fellows. And as is tradition, I will introduce them using 5 numbers. For our first featured guest, 1975 was the year that Alan Kay convinced her to take the altos to Palo Alto Middle School without permission. 2, the number of days it took to bring the altos back to PARC before getting permission. 1986 was the year the president of Xerox agreed to form PARC Place Systems. 18, the number of months that PARC Place holders operated within PARC until the Xerox lawyers completed the legal agreement. And 6, the number of books that she's authored, co-authored, or edited. She's currently the deputy chair of the Science Advisory Board for the Heidelberg Institute for Theoretical Studies in Germany. And at Xerox PARC, she co-developed the Smalltalk programming language with colleagues John Ingalls and Alan Kay, and was one of the founders of PARC Place Systems. Please welcome Adele Goldberg. Our next guest also could not join us in person this evening due to a very recent bicycle accident, but he was so determined to be with us that he is joining us virtually. Here are his 5 numbers. 36,000, the size of the Smalltalk 72 system definition, including comments. 2, the number of days it took to figure out the Smalltalk 76 virtual machine. 9, the number of months it took to build the Smalltalk virtual machine at Xerox PARC. And 9, the number of months it took to build and release Squeak Smalltalk at Apple. 6, the number of generations he created of the Smalltalk architecture. At Xerox PARC, he co-developed the Smalltalk programming environment with Adele Goldberg and Alan Kay. He designed the byte-coded virtual machine that made Smalltalk practical in 1976. And his most recent work, the Lively Kernel and Lively Web, the live composition and programming environment that runs entirely in a browser. Please welcome, virtually, Dan Ingalls. Here to moderate is John Markoff. He's an affiliate fellow at Stanford High, the Stanford Institute for Human-Centered AI. Previously, he was the business and technology reporter at the New York Times for about 30 years. A Pulitzer Prize winner, he's written 3 books about computer history, and we were thrilled to have him on stage earlier this year talking about Whole Earth, The Many Lives of Stuart Brand. And here at CHM, we're particularly happy to consider him part of the CHM family since he served as staff historian, and he's sat on our stage both as moderator and featured speaker many, many times. He is John Markoff. Join me in giving a very warm welcome to John. Thanks, John.
Oh dear.
Hi, everyone. We're going to intersperse our conversation with these really nice short videos from Alan, who's in England. And I just wanted, this is about the impact and the influence of Smalltalk, and I have 2 sort of personal thoughts. There are these moments that sort of define your world. And for me in Silicon Valley, which I've written about for about a half a century, 45 years, there are 2 that stand out in my mind. And one of them happened in Trestor Union at Stanford when I saw Space War for the first time. That was the first time I saw interactive television. But the second one, I went to high school with Ted Kaler, who was one of the team that developed Smalltalk. And Ted and I re-met at a certain point. And in probably 1979 or 1980, he showed me an alto in Smalltalk. And after you see something like that, your world is never the same. It resets everything. And that happened to me. Today I was sort of reliving some of this history. You know, Alan, this came up earlier. Alan wrote poetry. Alan Kay wrote poetry as much as he wrote code. And I really want to commend to you a piece that he wrote about the early history of Smalltalk when he was at Apple. It's called The Early History of Smalltalk, and it's a remarkable document. He captures the spirit, he captures the history, and it's really a poetic document. So take a look at it. It's on the web. It's easy to get. So why don't we start by running the first clip of Alan talking about the significance of Smalltalk at 50.
I think what's more interesting than 50, there are a lot of things I don't like in computing that are still around after 50 years. So to me, what's interesting is that Smalltalk was actually done well enough to still be interesting today. Not just as a historical curiosity, but it hasn't been adopted itself very strongly by the commercial computing, although it has in small places here and there, but it's still a very vital intellectual vehicle for the university and computer science community, especially in Europe. There are many dozens of papers every year that use Smalltalk and Smalltalk ideas as a base. So that's fun to see. So to me, the lesson to take from Smalltalk is not longevity, but that it really tried to be big in its way of encompassing things and small in what it took to do the encompassing. And that balance, I think, is something we should take with us into the future for the next 50 years.
That's great. That's great. So Alan had been a graduate student at the University of Utah. He built this machine called the Flex machine as a graduate student. Then he came briefly to the Stanford AI lab. He had what he described to me as a very unhappy first year at AI. And then Bob Taylor, who had come to Xerox PARC, who had also been in Utah after he had run DARPA, hired Alan to build this group called the Learning Research Group. And one of the things that he wrote, I wanted to start by asking you, one of the things he wrote in his history is that, quote, "I only hired people that got stars in our eyes when they heard about the notebook computer idea." What was this notebook computer idea? You wrote an article in the early 1970s about the Dynabook. Mm-hmm. Let's start with the Dynabook, and I want to ask you if you can actually pick apart Smalltalk from the Dynabook, or are they one and the same?
Alan used to walk around with a cardboard mock-up that was just a notebook-sized piece of cardboard with a drawing on the top. And he'd go to a conference and he would say, "This is the computer of the future, but what are we going to do with it?" And then we'd discuss an educational mission, we'd discuss a creativity multimedia mission. And two things that stand out, I remember, was that a reasonably well-known computer scientist in one of the conferences yelled out, "You're crazy." And of course, if you're doing research, you should be a little crazy, right? And the other thing that stood out is that we would get orders. "I want to buy one." And this was, in the 70s, and it didn't exist, but we thought it would take about 5 years to get that package. And so the question was, what kind of software is going to run on it? What kind of creative applications are going to run on it? How do they relate to one another? And will children be able to learn to grab the power of that computer by telling the computer what to do, which we call programming?
So I want to ask about education, but first I want to ask about your path to the Learning Research Group. When did you arrive? And I think you were a math person at Stanford, but you were also, I think, working with Patrick Suppies. And my sense is that was a very different kind of computer education, which was what went on at the Learning Research Group. Is that right?
Absolutely. So my path was, when I finished my undergraduate math degree, which was at the University of Michigan, the job opportunities were not very interesting to me. But I had gotten a programming job at the Center for Educational Research at Michigan, and got really excited about how you could bring this technology into changing, improving education. I then was invited, so I decided to go to graduate school, was at the University of Chicago when Patrick Suppies came as a in residence, and he invited me to Stanford. He was one of 3 NSF projects doing drill and practice. One of them wasn't exactly drill and practice, it was the Plato system. The other one was a system in Texas. And then Suppies had major math, symbolic logic, and reading programs with Dick Atkinson. So I spent a lot of time volunteering in the schools because I was appalled by that teletypewriter, appalled by what the kids were asked to do. It took them longer to log in on a time-shared system than to actually do their work. And I noticed some of the kids had figured out how not to be bored. They started taking the teletypewriter apart. But those are hardware people, and we were software. So John Schock and I met at an ACM user groups for the special interest groups on computer-assisted instruction.
And John was already working
in the
for
Bay Area.
Alan at that point.
And John was working with Alan, and John said, "Alan, you have to meet this woman." And so he brought me up. But that was my first encounter with Alan. It was I think it was early 1972. But I was already signed up to go to Brazil to teach down there for the year. Artificial intelligence, would you believe? And, but intelligent tutoring. And so when I came back, I went to see Alan, and he offered me a job that I would have paid him to let me do. I mean, it looked like so much fun, but more importantly, he was proposing to give a tool to education so that when you wanted it, it was there with you. You were carrying it around like paper and pencil. And this big time shared drill and practice I wasn't excited about.
What about this tight coupling between the sort of the vision of Smalltalk and education? Why education? And it seems like it was a very different kind of education than the drill and practice stuff. This is more in the Montessori or Piaget direction.
So this was more about the computation, the collaboration, the communication potential of computers in the early 70s. And we see a lot of that now today, so I think people understand what we're saying. But I think you really needed to upend education. You needed to give kids the practice of looking at the world and saying, I understand that, here's how I understand it. And so really, for me, wasn't a programming environment. It was a modeling environment, and an environment in which you could say to other people, here's how I think that works, whether it's physical or social. And then other people could say, oh no, you forgot, what about this data? What about this? And I was at a learning workshop that Alan put on when he was at Apple, and there were a lot of well-known computer scientists. They are, very accomplished. And I said, how did you learn what you learned? How did you become who you are? And they all said, well, we would make up how things work, and we would ask a parent, and the parent would say, what about this? What about this data? What about this instance? So you can see that you didn't just have to have a modeling environment, you needed a mentor. You needed someone who could draw the data and the examples.
Yeah. Alan traces the inspiration of Smalltalk back to Papert and Logo. Were you familiar with Logo and Papert before you came?
Sure.
Did you know that? And,
sure.
Trace that influence.
So there were lots of projects across the world that were interested in what Papert was saying about Logo and about turtle geometry. More turtle geometry than Logo more generally. And it was kind of the first of example that I think all of us saw of being able to take a mathematical idea and see it physical. Of course, what Papert used to do was jump on a table and pretend he was a turtle. Where he and I differed, and where Alan let me run with it, is you can't expect teachers in our schools to jump on tables and pretend they're turtles. Plus, it isn't just about, you need a lot of examples, you need a lot of models. And so I really feel strongly then, I felt strongly then, and I feel strongly now, that you test your software ideas about programming language and existing models and existing tools that are part of a programming environment, I like to say modeling environment, with curriculum. And I know a lot of people around the world who tried to teach Logo or variations on Logo, and they were failing. The kids were not getting excited, and they just needed that kind of help. They needed to understand what are you supposed to do.
Yeah. Let's talk about some of the basics. In the early 1970s, how radical was the idea of an object-oriented language? What was that world like? I mean, what I remember is I remember Pascal, I remember BASIC, I remember C, but where does Smalltalk fit in?
So Alan usually tells the story of the first time he saw Simulus 68, which was really intended a simulation environment with objects, but not purely all objects, not purely message sending. Whenever he would get the group together and want us to remember the past, it was Ivan Sutherland and Sketchpad. And that was not just an object-based system, but one where their visualization was there and you could touch and change things. So there was a lot of build on the shoulders of those ideas. But at the same time, you wanted something that had an immediacy, had Dan Ingalls were here, he'd say a liveliness, that you could change it, in place, because kids like to play with clay. And clay should have been our model for that.
We're about to play a clip from Alan talking about the impact of Smalltalk on education. Why don't we listen to that, and then we'll bring Dan in.
So we wanted to start with a computer language that was readable by children and have it still be interesting when they got older. I think that the idea of a programming language that would serve the same place for representing ideas as mathematics does and as natural language does was a very interesting thing to try and attempt in the world of the child. So I feel like we did a fairly good job starting out there. We did, in subsequent history, some of us kept at it for quite a number of years and did numerous follow-on languages for children, many of them implemented in Smalltalk. And one of them was fairly successful, which was called eToys. And its progeny was Scratch. And Scratch has been very successful out in the world, although it a bit at the price of giving up some of the early ideals. The early ideals had to do with how people think about things, not about how they implement code.
In 1977,
the computer science lab devised a plan to invite the top 10 Xerox executives to the Palo Alto Research Center to learn about a components-based approach to developing software. The Smalltalk group was asked to create a hands-on workshop in which these executives could personally experience this new approach to software architecture. I created a modeling environment in the Smalltalk 76 system that provided the parts for discrete event-driven simulation. Parts consisted of simulation framework, stations, workers, and jobs. The library seen here in a browser constrained only to show the parts of the simulation that are appropriate to be changed. For the workshop, we created a curriculum based on having the participants define Xerox relevant simulations. For example, a copier duplicator store, a copier room in an office complex, and the production line for packaging Versatech products. Here we selected the Versatech simulation and can cycle through the arrival of the jobs, which are PC boards, to be set up, stuffed, inspected, and soldered. Let's run it at full speed and see what happens. What we're seeing is a bottleneck building up and stuffing. Either we need more stuffers as workers, or fewer PC boards arriving to be packaged, or perhaps the existing workers need to work faster. Let's open up the browser. Let's find the jobs for PC boards, and let's find where the PC board informs the worker how much time, how complicated it is. I found out that there's complications that get very, very high. So let's not have such complicated choices. And we'll just make the change and accept it. Now we'll refresh it, we'll restart, and we'll run it again with the change already accepted. Yes, that looks a lot better.
The squeak objects in eToys are called morphs. You can click on any morph to get a halo of possible commands, such as rotate or resize. The blue eye in the halo will open a viewer. You can see that if I move the car concretely, the analytical X and Y values in its viewer update accordingly. If I change X and Y in the viewer, the car moves correspondingly in its world. Students immediately understand this relation between abstract and concrete views. The viewer shows messages as well. Here I can invoke forward or turn with the exclamation mark. You can build a script by dragging messages from the viewer into the world. Now I can run the script to make the car run around in a circle. This tutorial features a script that makes the car bounce off colored objects. Other morph features enhance learning, such as the ability to put a pin down to record motion. eToys was the basis of early work on Scratch.
So I wanted to bring a little bit of context here to this question of education and Smalltalk, because, you know, Alan, as a graduate student, received a visit from Doug Engelbart. Engelbart was working on this system called the online system in 1967. And Engelbart had a view of a metaphor for computing which was based on the car. I mean, it was a radical break from IBM, which was railroads. Engelbart saw a computer as an automotive kind of metaphor where you drove through cyberspace. And I think one of the most important contributions that Alan made is he actually understood that computing was going to be a media, and it was going to be a universal media. And he wrote in an early history of, he described this really well in an early history of Smalltalk. He said, with a vehicle one could wait until high school and give, quote, driver's ed, but it is with a medium, it had to extend into the world of children. And that was the first time I sort of got why children. Can you guys both talk a little bit about that? Computing as a universal medium and Smalltalk?
Why don't we start with Dan?
Yeah, Dan, could you start?
Well, I think the most important thing to me about that little demonstration has to do with the direct connection. And it's what Adele was also talking about with the executives, which is when you see something happening that you've described, you understand it viscerally. And if you go and make a change in it and see that change, again, it's visceral. Similarly, with the little car running around, you have that feeling. And a child having seen that demonstration, if the car goes under something else, the child will know that the car is there at that position, which is something that kids don't get without having that kind of direct connection. So I don't know if that speaks directly to what Alan was talking about, but to me, that's the important thing that ties these two together.
What about computing as a media and education?
So we have a challenge, and that challenge is when you give something to a child, they may understand it as something appropriate for their age, and then there's something they get from that, but it gets pushed away. You know, Puff the Magic Dragon sort of comes to mind. And our challenge was much harder, which is if you teach somebody an initial programming experience, what you're hoping is that you can filter what they see so that they're not shocked or scared by it. And the simulation kit was my first opportunity to demonstrate that. Like, even when you went to debug, you did not see anything but what was an object in the simulation kit. But you still need to do a progressive unfolding. And natural language is like that. You know, children learn certain constructs, simple words, and they add to it. But what they learned is still true. So part of the challenge of the kind of programming language, but also the modeling world, is that what you teach them has to be true and has to stay true. It's not nice to say, well, we didn't think you were smart enough yet, or adult enough, or mature enough is the word I'm looking for yet, so we lied a little bit. So you really can't do it because you turn the child off. But if you give them a lot of examples and they can read the example and then modify it, all right, then you've done something that you may criticize as software engineering, which is having existing components and reusing them and modifying them for your situation, but it is very much an educational problem.
Dan, you've said elsewhere that you were, I mean, one of your sort of reasons for existing was taking this technology and getting it out to as broad an audience as you possibly could. Why did you pick education? Throughout your career, you've worked within the framework of a programming language for education for children. Was that kind of a stealth strategy? Did you want to, get to the world through children?
I think, and this is probably true for many people, it began for me as a child because I wanted something like that as a child, and that's a kind of a visceral passion, and what just amazed me was as soon as you expanded things from just numbers to being able to model any sort of an object as the things in an equation or something like that. Suddenly you could be talking about musical notes and their pitch and their duration and their timbre. You could be talking about lines and their color and their width. But underneath it, the structure is still the same. You've got objects with these various properties and you talk to them with messages. And the messaging is really important. We can get to that later, maybe.
Actually, let's talk a little bit more about that, because one of the things that Alan said to me once, that he was, he thought it was unfortunate that the object metaphor had gained such supremacy. He felt that messaging was maybe as important as a metaphor in programming as the object. Is that an important way of looking at it, or an important way of reframing it?
Yes, well, I feel so. And to the extent that, if you look at the really fun demos we've given, where something totally unusual happens on the screen, it's because something gets hooked up to something else that you would not think could possibly be so. So you've got maybe a browser being turned on its side. How can that be? And yet, that's just a manifestation of all the descriptions that are there, if the mathematics is true. So to me, the importance of messaging is that you can, if things are connected by messages, you can talk across that gap. You can say that this thing over here actually turns when this thing gets read, or you're in the position of being able to script the world, essentially. And that's the importance. And it's super important as soon as systems grow in their strength of describing different kinds of objects.
Yeah. So Smalltalk was accredited with sort of being the world in which the graphical user interface came to the world. And I'm trying to understand, so the graphical user interface was necessary because you wanted to write a system for, as Alan described it, children of all ages? Was it that push to simplicity that made a graphical user interface necessary?
So let's see. I don't think so, but Alan's not here, so he can't tell you exactly. But there certainly are great interfaces for kids that are not, rectangular windows on the screen. And the number one thing to get the kids is to let them see the way you've set up the world. So if the world is set up with a dictionary of 100 things that you can do, then you want to have some manifestation of that they can get to iconically, ideally just by sort of pointing and clicking on them. I don't know.
What's your sense?
What I would say is that, especially, I mean, it's not just young children. Human beings tend to understand something that they see. I thought the simulation kit demo there was really significant in that, and certainly Silicon Graphics had a lot of visualization about data and what was going on that were just, waving wheat. And those kinds of examples draw your attention to something you might miss, you might not see otherwise. So the struggle here is to say there's underlying models, and how do you understand that model, and how do you understand it at different levels of complexity? So how can you progressively unfold the natural complexity of a model and not have the person miss it, and visualization and the ability to touch and to hear, go along with being able to see. So there's where that multimedia becomes so important, because it's how we communicate.
But wasn't there this sort of drive towards simplicity and scaling? I mean, in some ways, the Smalltalk system was a reaction to the online system, which was deeply committed to complexity. I mean, Engelbart believed there should be at least 10 buttons on the mouse. He thought there should be 50,000 commands in the online system, and that you became a skilled user. And I know Larry Tesler, who was one of the early Smalltalk designers, reacted dramatically against it. He was one of the first people to believe in simplicity, and I thought that he believed that in the context of the design of Smalltalk.
Well, he did a number. Yeah, go ahead.
Well, so yeah, I felt that certainly, and in just thinking about the culture of our group into Xerox PARC also, the phrase "small is beautiful" echoed there, and we really picked it up. And if you look at the systems I built and the code I've done, I was always trying to see how much smaller you could make a given thing. But it's not just a toy exercise. It's that if things can be made small, then the only way you can accomplish what you're after is if they're also general. And so you see these beautiful sort of nexus things in computer science and in all of science, where there's a small set of rules that are general and that cover everything. Like the first Lisp interpreter was that way, or the rules of electromagnetic propagation. Where you've just got like 4 equations, and out of that comes all of radio and the whole spectrum. So that's the thing about. So there was that small is beautiful, and that desire to distill things down to a small point, and that was something that I loved about the challenge of working with the microcoded computers at Xerox, which is you had to do that, actually. If you had a good idea, if you could get it down small enough, it could go into this memory that suddenly ran 5 times faster. So it's like you had the magic sparks in your fingers if you could do that.
That's evocative of something that Chuck Thacker once said when he talked about seeing the online the online system demonstrated by Doug Engelbart. He saw that in a videotape at the Learning Research Group, and he said that he thought that Engelbart sat on stage dealing lightning with both hands. Thereby the dealers of lightning that came later at Xerox PARC. Before we hear from Alan, I wanted to ask you both a little bit about the culture of the Learning Research Group that developed Smalltalk. And I wanted to start by reading something that Alan wrote about your group and getting you to react to it. A lot of daytime was spent outside of PARC, playing tennis, bike riding, drinking beer, eating Chinese food, and constantly talking about the Dynabook and its potential to amplify human reach and bring new ways of thinking to a faltering civilization that desperately needed it. That kind of goal was common in California in the aftermath of the 60s. Does that evoke memories?
Oh, yeah. Oh, yeah. There were the poker games. There were the late nights at the Oasis that people remember. When you're doing something that doesn't exist and you're trying to accomplish a small, readable, understandable approach to being able to do something that doesn't exist but has that level of abstraction that Dan just mentioned, then it's a hard problem. But if instead you do it in the context of having a good time, you stop thinking it's hard, and to quote Dan, you just do it and it's done.
Yeah.
Right, Dan?
Yeah, right.
But was that, for you guys both, was that the Learning Research Group a singular experience? Did you have other development projects that built groups like that, or was that a one-off? How unique was it?
You mean in after PARC or before?
No, during the Learning Research Group that came together in the 1970s, at that point in time, that developed the first versions of Smalltalk. How unusual was that group? You've been involved in many software.
A lot of it was unusual because of the way Alan didn't run it. I mean, he did not micromanage. He would just pop in with, let's play music and listen to what you hear. That's Bach. You know, he was always teaching something. And you really had to think hard, what's the point? And then you say, there is no point. The point, or if there's a point, it's that we're here to create something that we enjoy because then other people will enjoy it as well. So it wasn't just to get a result, it was to get a result that would stimulate.
Yeah.
So I have a slightly different, oh, go ahead.
Go ahead, Dan.
Yeah. So, yeah, I think that's really true. But when Alan would, for instance, introduce us to some really neat music, to me, it was also to inspire us. And in our later group where we did Squeak, we went to see what's the Cirque du Soleil, sorry, which was also inspiring. Just to and when you go out and are athletic, and we played volleyball a lot, and it lets that rational part of your brain stop a bit, and sort of the other things that may be forming them in the other parts of your brain come out more to the fore. So I think all of those sort of side activities are important to a group that is that's exploring, and that's not to say that we were the only ones, but we were creative that way.
Yeah.
It's one more thing. So there's something else that should be said, that the way the group worked, we trusted one another. And that really spoke to taking risks. So I think the simulation kit was a good example of it. He knows what I'm going to say. He's laughing. Basically, it was my turn to have an alto at home because I had just had my second child. And I would just come in at night with her. Somebody would walk the hallways. And we were building this in Smalltalk 76, where I believed that we had the ability to create class hierarchies. And nobody said there was a limit to that. And the ability to do what we did, which was allow people from corporate, the president was an ex-programmer, but most of them not programmers, but allow them, everyone in the room doing something different, and to have built all that in a couple months was pretty unprecedented. But what we don't always talk about is what happened, was it a week beforehand? When Ted Kaler and Dave Robson came to me and said, we have a problem. And of course, they wouldn't have come if they didn't have a solution. And the problem is, it wasn't true. You could not build a class hierarchy that was as deep as you wanted to. And this curriculum, because I was driving everything from a curriculum, was really testing the system. And I said, well, what do you suggest? They said, well, the worst case is that we cut back what we do with them so that they don't hit the limit. Alternatively, we replace the entire virtual memory. And I said, do you know how? And Dave and Ted smiled and said, right? Sure we do. And I said, go for it. Go for it. And I don't know if you realize, that's a deep trust. And that's what we were like.
Let's hear Alan talk about programming languages.
Smalltalk has been a good thing to point at when people want to invoke the power of object-oriented programming. Look what these guys did back in the 70s with this and 10,000 lines of code type stuff. But in fact, some of the reasons we were able to do that, the amazing stuff in the 70s with a few thousand lines of code, have been omitted from most modern languages. The difference between the mechanics of something like Smalltalk and something like Java or Python or so is not a lot in certain respects. The difference in what you might call the meta level languages that are employed, the meta levels that are used, and especially the difference in the approach to what a system is and programming a system couldn't be more different. Ruby is an interesting example because it is in many respects the most Smalltalk-like of the modern languages, and has been quite successful. They did an excellent job with it, and I certainly wouldn't criticize it. I would just point out, if you look below the surface, there's less there than Smalltalk has. Similarly, if you look at a language like JavaScript, which people malign, but I don't, JavaScript is a little bit of a hodgepodge, but underneath it has both a model that I think of as being a bit more like Lisp, and a really solid set of foundations, including a really great garbage collector. It has fabulous optimization mechanisms. So it's a little bit of a scattershot of a language, but as something to treat, for example, as the machine code of the next machine you want to turn into something wonderful, JavaScript is actually pretty good for the reasons that Lisp is pretty good. You've got this dynamic language, you've got something where things run pretty fast, you've got WebAssembly if you want to make things run even faster. So it, in my opinion, it is probably the simplest go-to place for both doing experiments and doing things that you want to deploy today. So I wouldn't run JavaScript down, even though I could complain about it not having a strong enough meta system to allow a really good debugger to be written in itself. That's always a test of a language, and Smalltalk passed that test, and most of the other languages don't.
So Dan, let me get you to react to something Alan wrote, which I think you sort of spoke to earlier, but he wrote in that article, in computer terms, Smalltalk is a recursion on the notion of the computer itself. What did he mean? And sort of, were you getting at that when you were talking earlier?
To a certain extent, yes. And I think Alan continues to see this more purely than I, and maybe someday I'll make it there. But essentially, if you have a model that's a model of object sending messages, the whole, any whole world, let's say, can be described that way. And that's what the projects and worlds are like in Squeak. That's what the worlds are like in Lively Kernel. And you can take one of those and now treat that as an object and talk to it from the outside. And now it's just a simple thing in a more complicated cosmos. And yes, that should expand on out to the point that you're describing anything in the universe.
I'd like to ask you both to talk about Smalltalk in the marketplace and sort of where it succeeded, where it failed, why it didn't at a certain point become the dominant programming environment for the entire world when that was kind of an open option at some point. Was that because of the nature of the language, or was it because of errors or lack of opportunities that Xerox missed? What's your assessment of the sort of economic side of Smalltalk?
So, this is not a simple answer, and of course we'll never know, but we were the first out with this type of environment. There was the Lisp environment, but that was a very targeted market. And the market that Park Place Systems went after was the all the standard U.S. industries, whether it's financial, transportation and shipping, or manufacturing, or telecommunications, automotive, people who really, they rely on their systems, they understand their business models, or they think they do, and they're missing something. And one of the things they were missing was graphical user interface. This was all new for them. So there was a lot to learn. We didn't have the money to give it away, which would have been nice.
You didn't have, what does that mean?
As I once said to a person, I have to pay the salaries of some very expensive people, not as expensive as today, thank goodness. And I do think it's my obligation as CEO to make sure their families have food on the table. So we have to pay the bills. And so we struggled with the business model that would work. And software companies, in order to get out of Xerox, I did the business plan, and the it's not very well known, but the CFO of Apple was kind enough to look at the business plan that I was going to present to Xerox, and he said, no, this won't work. And I said, why not? He said, well, your profit margin's 18%, they won't believe you, and it's all software. So you're going to have to pad this with more expenses. So I presented them with some hardware, and it lowers the margin. But that was typical of that day. This was mid-'80s, 86. And raising money was complicated for a whole lot of reasons. So we didn't have a lot, which meant that we could not do the kind of programs that Sun Microsystem can do to just blanket Java. Yeah. And we saw it coming. We knew this was going to be an issue. And when I was running the company, we tried to hold the course. What was really important was to make sure people were successful. And so you end up with maybe fewer customers, but they were all amazing success stories. There was a conference in the Northwest where the keynote speaker said, we're not asking you to rewrite your accounting system. It's for new things that have graphics. The next speaker was one of my customers from well-known automotive industry, and he said, we're rewriting our accounting system. And here's why. The unions come to us with new compensation plans that are perfectly reasonable, and we have to say no, because we can't change what we have, and certainly can't change it fast enough. And they got the core idea here, which is if you restructure with objects, you have predictable change. And so then they can start saying yes to the unions. And that's the kind of thing we learned being out in the real world. What kind of models were being built, what level the systems, what mattered to the various people, and they could start incrementally building their systems. So we had to change not just the kind of architecture they were doing, but how they worked. Yeah. And it really relied on a very large, smart, capable professional services organization.
Yeah. Dan, do you have a similar or different view?
Yeah, well, it's different, but not opposed necessarily. But I think there are several ways of dealing with that. I mean, one of them is the Red Hat software way, which is you give it away, but you provide services to support it. And I think to a greater or lesser extent, that's how Adele wound up making some of her ends meet. But another thing is we missed a couple of opportunities. I thought we really missed an opportunity with Unix really early on, because it had real market share, and we had a system that at the user interface level was the same kind of thing that it was underneath. And I think they would have played well together and made a good package, and we could have, sort of leveraged both our expansion in the world and money made from it off of that. And the Strongtalk thing is a whole other story, but we probably don't have the time to go into that.
Let's hear from Alan on the impact of Smalltalk.
And I think the most obvious thing about the whole system is not even the language, but the user interface, because the elements of that user interface are the elements that are still in use these many decades later, for better or worse. So I wanted the children to be able to do anything that the adults could do, but we had to think about what it would be like for them, what was their experience. And whereas Engelbart's system more or less was essentially like a violin. It took 10 or 15 hours of use of Engelbart's system to get fluent enough in it. But it was designed to be used by adult professionals that were trained. That was part of Engelbart's original manifesto. And that was not our manifesto for children. And so a lot of the stuff that we thought of was done the way it was done because of children. And of course, adults, as they prove over and over again, are often not much better than children as far as sophistication and ability to learn and stuff like that. And so that user interface became very popular with adults, even though it's not that good for them. I think the main thing about the Smalltalk interface is that Steve Jobs saw it at a critical time. And as he said later, he missed objects, but compared to most business people, Steve Jobs could see more. Couldn't see a lot, but he could see more. And he realized the important thing was that if you're going to do widespread computing, which was the whole goal of personal computing, you have to solve a user interface problem.
So much, the central myth in some ways of Silicon Valley is that visit that Steve made. And even tonight, I've heard different interpretations of what actually happened. I mean, on stage at the same time. It's really quite remarkable. Let me just read something very briefly about Alan writing about that demonstration. One of the best parts of the demo was when Steve Jobs said he didn't like the bit style scrolling we were using and asked if we could do it in a smooth, continuous style. In less than a minute, Dan Ingalls, found the methods involved, made the relatively major changes, and scrolling was now continuous. This shocked the visitors, especially programmers among them, as they had never seen a really powerful incremental system before. That kind of programming environment that has always been in the Smalltalk world, how much is that a reality for the entire programming world at this point? Is that the standard of computing software design, or is that still not a reality?
I don't know.
So there's sort of two sides of it always, you know. Yes, when the situation is right, it's that way. And we had built a system from the ground up, and therefore it was quite nicely factored, and it was being demonstrated by the guy who put it together. So, you know, I knew how things worked and I knew where to go. But it's definitely the case that if systems in general are well factored, well thought out, they can be worked on much more efficiently than systems that are not. And you know, I talked to some people in doing big software projects, and there's a real problem in any big company, which is you get this bulk of code, and then something new gets added to it, and you're a new guy working there. What are you going to do? Well, you're going to glue something on and find out the way to make it work. And you won't know the thing that's beautiful and down on the bottom that would have made it trivial. And so you add on your own version of that. And this goes on until the whole thing is full of things that don't relate instead of being factored. So that if you now want to make a change in that kernel aspect, you can't. But if it were well factored, you could. And so that's almost the most important thing at the bottom of object-oriented design.
So at this point, I mean, I could. Okay, thank you. I have dozens of other questions, but I want to bring the audience in. I want to be mindful of our time. And this keeps coming up. This is a question from Gio Wielderhold from Stanford. What would have happened if Xerox had made Smalltalk available in 1978 when CMU, MIT, and Stanford, when Xerox provided a dozen Altos to those schools? Did you provide them with Altos without providing them Smalltalk? Was there a disconnect? No.
No, we weren't part of that.
Okay.
We got the Altos. We didn't get Smalltalk, which was the reason why I wanted the Altos. Because I supervised the student Alan Borning, who did SimLab at Xerox.
Do you know this history? No.
And I was so pissed off that we only got elegant text editing machines that I never touched them.
Okay, so you're bringing up something that is not consistent with the way large corporate bureaucracies work. And one of those is, you could call it chain of command if you want, but I'll just call it communications. There are a lot of stuff that goes on and reasons that go on, why Altos went where they went, that had nothing to do with a very small team focused on a different problem. And no one ever asked the question to us, well, what would we need from the universities to release something that would be properly supported? As it was, shortly after that, I had discovered that one of the Xerox divisions had picked up the research without permission or communication and had used it in major contracts in the intelligence community. And the way that unfolded was one day, the administrative head of the CIA was sitting in a room with me, growling at the product division managers who were there, saying, I didn't ask to talk to you. And he just sat there waiting till they left, and he said to me, where's the support going to come from? And you could do a Red Hat type thing, but there was still a model for support. And it wasn't just ground up, there was central. You know, it's like the Python guru who says he's the emperor of the world forever, you know. There was nobody prepared at the time to step up to do that worked. And it's easy to criticize after the fact, but you have to ask yourself, what could we have done? We did a lot of Unix stuff. Those were our first products. Those were the first machines that came from companies, but we knew nothing about any of that.
Wait. We'll go on. You can have this conversation with her later this evening. Dan, there have been a number of questions about the idea of live programming. Could you introduce it and talk to what extent it exists in the world today?
Sure, yeah. And most of the Smalltalk systems are designed that way. And it's not something that's unique to us. The Self system did a great deal of work that way. But it comes down to that, there you go. It comes down to the fact that of making the structures that define the universe you're working with, the application you're working with, are not frozen in concrete. They're not compiled out. They're actually there and can be changed. And in some cases, we'll have user interface affordances hooked up to them so that, for instance, you can easily change their scale or their color or whatever. And this is, so systems that have been around for a while get worked on so that they have controls for the various things that people want to control. But typically, there are things that you might want to control that there's no way to do because it wasn't anticipated. And so the systems that were not designed to sort of be able to do anything or be general in that way are more frozen. It doesn't mean they're bad. You know, some people want a word processor that only does this and that, and they get confused or angry if it does something else. Yeah. But you want to be able to have some way to get in there, sort of to get under the hood is the phrase that Alan used to use, and actually make it do the thing you want to if it really has all that power. And typically, Smalltalk systems and other systems like that do retain that power underneath, and you can get at it, and in some cases have nice general interfaces for getting at it.
Okay. Adele, yeah. There's a notion that appeared, I think, from a researcher at CMU a number of years ago, which was called computational thinking. And I was wondering if you're familiar with that idea and if that sort of meshes with the educational learning philosophy of Smalltalk.
Yes, I'm familiar with it. In fact, we were in Toronto for part of this 50-year celebration, and I had reviewed some of that. And it's not general purpose modeling. It's a very specific notion of what it means to compute, right? Whereas we would include communication issues, visualization issues, things that maybe don't look like mathematics. And I don't think that everybody needs to think that way to be successful in their use of a Dynabook.
Interesting. Okay.
I do think, though, that we need libraries of models that people can read and learn from and modify and explore. And this was something that when Donald Knuth broke his arm and couldn't write programs, he then said, it was the best time because I read programs and I learned so much.
Interesting. This is my vote for the quirkiest question. And it starts, you once said, and I'm not sure who you is, but quote, computers should not make noise. What is your opinion now? Did either of you say that, or did Alan say that? Adele said that?
Adele, they shouldn't make noise?
Should not make noise.
Oh, yes. So the very first experience I had programming was unit record equipment, accounting machines from IBM. And a lot of you know, I mean, this is punch cards, but the way you program it is you wire boards, right? And when you put it in and everything's happening, it's making a lot of noise. And you know whether it's working or not by the noise you're hearing, which is very weird.
Yeah.
Is that what The conversation, yeah.
Okay, well, computers should be seen and not heard. Let's agree on that.
Not true. The music is wonderful.
So I wanted to, this didn't come up earlier, but you know, the style of programming that goes on today often involves finding code that already exists on the internet and putting it together. It's moving in a direction, I think GitHub not long ago introduced a system I believe is called Pilot, which actually completes, using language models to complete code. How does that fit into the sort of trajectory you guys began on with Smalltalk, these new models of programming?
So I don't see that just quite being in the direction we went. Okay, so yes, you can actually make code that way, and one should be experimenting with ways to do that. So the internet is full of lots of code, some of it good, some of it not. And if you do a search, pattern matching is a great strategy, and is at the core of some very interesting programming languages. So if you can then take, if you have a problem to solve, take a pattern and go match it against everything out there and see what comes back and try it out. But it's a little bit like, well, you'd call it shotgun programming, but it's not the way you necessarily invent something, but it could be the way you solve a problem. That's my feeling. And I wouldn't necessarily steer kids in that direction, except in the sense of showing them how you could do this, and it's a way of turning the engine on a certain facet to get a result.
Okay. So we're at 8:15 now, and I'm conscious of your time. I just wanted to sort of note one bit of history and a personal disappointment. It didn't come up tonight, but at a certain point, Adele, in a very complicated way, took a couple of altos to a local junior high school. And it was all part of this strategy to bring up a generation. I guess they were called PARC kids at one point. A lot of teenagers and even younger kids were taught to program. And let me conclude by saying one of my great regrets is I went to that junior high school, Jordan, 10 years too early, and I missed the computers. So thank you very much, both of you, for your time this evening.
That's funny.
No, you're not getting off yet. Thank you, John, Adele, Dan, and Alan. We miss Alan. He's in London, but he contributed a lot to the program and obviously a lot to this whole event this evening. And I know we're all missing him and wish that he was here tonight. So I'd like to thank you all, and I'd like to thank the panelists. One of my takeaways tonight was that small is really beautiful, and yet at the same time, it can have a big impact. And when you were talking about culture, which is, I think, also fundamental to the conversation this evening, it made me think about, and some of you will remember this or maybe even participated in it, the notion of a K-lock. Who remembers that? IBM used to pay their programmers on the number of lines of code that they wrote.
Oh, right.
So thousands of lines of code was really the big idea, because after all, that was Big Blue. And you kind of look and see that the lasting efforts were those that were really reducing things to a place where they could be abstracted and used in so many different ways and shared. And that all just boils down to the culture that we all experience tonight with this program. So thank you for that. Those in the audience, we really want to understand what your takeaway is. Our goal is to decode things and to see what you've learned. So you have a QR code that's in the materials that was presented at your chair. If you would take a few minutes and take the survey for us, we really would appreciate it. Our goal is to reach millions of people around the world as we implement our internal systems to scale. We're working small and then going large. And the goal, obviously, is to measure impact and evolve this institution into one that scales around the world. And so with that in mind, if you're not a member, please consider joining. Go to the website, Join and Give is the place to go. And I'll just close by thanking you all for coming out this evening. And again, another round of applause for our panelists tonight. Thanks. Come. Oh, we have one. Oh, Marguerite, you gonna do this? All right, so yeah, I jumped the gun. My goodness, you guys sent me up here a little bit too early. We have this tradition at the museum that Marguerite has institutionalized, and it's called one word. And John, you're going to kick it off, right?
No, I think it's.
All right, so Adele.
It's Adele, yeah.
And Dan.
And Dan.
All right, so Dan, you go first.
Oh, so I get to say one word? All right, so I'll give you this.
Unanticipated.
Is that readable? Yeah.
No, to your left.
This way.
Yeah.
There it is.
There we go. Yeah. Right.
Unanticipated. All right, great.
So
And by now,
there are.
yeah, go ahead.
Go ahead and explain that.
Yeah. So this has a very immediate meaning to me with regards to the fact that I couldn't attend today. So the world throws all sorts of stuff at you, and you have to be ready for anything. So that's the first part. But the other part is a serious aspect of software design, or I guess you'd call it that, which is that I think that if a system is going to support creativity, it has to support unanticipated connections. And that thing I was talking about earlier of the sort of, really fun demos that we would give, or something where you go, oh my God, at the end, it has to do with this ability to bridge across different parts in art. So that's what it means to me.
Perfect. Thank you. Great, Adele.
So I was told one word that is advice.
It is advice.
And so it will be no surprise that I chose ask. Now, there's no shame in not knowing something, or not having a skill, or not knowing somebody. You just ask, and that person will, whoever you ask, will take a whole chain, and sooner or later you've learned how to do something. The only thing you shouldn't ask is for permission.
Very good. Thank you. Thanks, everyone.